4 from the 2014 exam, this is one of those questions that was really a lot of writing, wasn't it? Okay? And depending on how you answered, and if you answered according to the rubric, you could go anywhere from a 0 to a 4, right? It's a really wide variety of possibilities. Did you hit every point they were looking for? So I thought this was a good question to look at some feedback in a different way. Okay? You've already answered it the way you think it should be answered. We'll look at the rubric in a minute. But I thought it was a good idea to look at what the College Board thought was the intent, how other students performed on this test. I'm trying to make it bigger here so we can read it. There we go. So the intent was basically to describe what why a median might be preferred over a mean, okay, and be able to compare two sampling plans and describe a consequence for using one of them, okay, or consequence of non-response, sorry. So on this question last year, the average score, the mean score out of 4 was a 1.79, and it had a standard deviation of about 1.16, okay? So kind of give you a feel about how you would score compared to the rest of the country, okay? I'm sorry? Mean was 1.79, right here. 1.79 and 1.16 is the standard deviation, okay? What were some common errors? Okay, so let's look at what some errors were and see if you fall into any of those categories. It says many students provided only generic statements about how outliers or skewness affect the mean and do not affect the median without making a connection to a conjecture about outliers or skewness in the distribution of incomes. So I'm thinking they're talking about context there, but we'll have to make sure, and we'll look at the rubric. Some students neglected to mention the effect of skewness or outliers on the mean. For example, by saying only that one should use the mean when outliers or skewness are evident and not why. Okay? So by saying that outliers or skewness pulls the mean in the direction of that tail, that would be an evidence as to why. Okay? So you have to make sure that you're making those connections. Let's see what else they say. Oops. So it says, hang on, a lot more issues. Okay, for part B, some students did not explicitly say, I wanted one or the other, because didn't they give you a choice between two? Okay. Some students chose method 1 based just on the larger sample size, ignoring the issues that it had. Many students gave good arguments for the weakness of method 1, but did not specify advantages of method 2. So that is something that you should think about. If you're ever given two scenarios and you're asked to pick one, it's a good idea to say why one doesn't work and why the other one should work. You want to think about advantages and disadvantages of what you chose. Okay? So that's something we should be thinking about when you're given two to choose from. Some students named the type of bias incorrectly. We're going to look at the grading rubric in a minute. They discussed, I think it was the possibility of non-response, even though the question stated that all responses would be obtained in method 2. So method 2 does not have non-response because it clearly states that they're going to be all collected. I like this one. Many students use the ambiguous statement that results will be more accurate when commenting on methods 2 effect. So it's like, why was it more accurate? Okay. And they discuss conditions for inference when choosing the two methods. But if they did that, then error would be that you did it incorrectly. Okay. So I thought that was interesting. So what I'd like for you to do is I've given every table a sample of a different student and their score. Okay. So we're going to score our own papers first. And then I want you to score the sample paper. And I want you to tell me what they got. So just keep the sample paper off to the side for now. We're not going to look at it quite yet. We're going to score our own according to the rubric, and then we're going to score the sample papers. Sometimes it's a good idea to score somebody else's work and see what was a good paper versus not a good paper. And there are a variety of different ones, okay? Although the sample papers I picked that you guys have score, some are very good, some are not so good. So it just depends. Okay? So let's go ahead and look at the rubric itself. I think this is it. Let me double check. Question 4. Here we go. All right. Whoa. It's at the beginning. Here we go. The intent of the question. Oh, this is the wrong one. Sugar. That's question 2013. All right, so hang on. Let me pick the right one. Am I looking at the right question, you guys? All right, so 2014 is what we wanted, right? Oh, you guys are looking at 13? No. Hang on. But the one I printed the wrong copies for you. Crumble those up. Recycle them next to Judith. Oh, that's true. We can reuse them. Thank you, Amanda. Amanda will collect them for us, and we will use these sample papers for a different question. But let me print out the right ones. Okay, so here's the intent of your question. Okay. So that's what we already looked at, the intent. The solution is for part A was that the median is less affected by skewness and outliers than the mean. Hopefully you guys knew that. But you need to put it in context. With a variable such as income, a small number of very large incomes could dramatically increase the mean, but not the median. Therefore, the median would provide a better estimate of a typical income value. That's the ideal answer. Obviously, you know, and not all of you are going to say exactly that. Hunter? Not necessarily. Median is only a measure of center, not a good representative. It's a better estimate. That's what it's asking you to choose. Well, hang on. It's asking you to choose which one would be a better estimate, the mean or the median. As long as you tied it to the skewness and the outliers, it should be okay. One or the other, I think, is okay. But let me look at the grading rubric to make sure. Okay. So part B, you had to specifically say that method 2 is better than method 1. Method 1 could be biased because of the voluntary nature of the response. So I'm assuming they're going to make you identify the type of bias that exists. And you would explain in context it's plausible that class members with larger incomes might be more likely to return the form than the members with smaller incomes. The mean income would overestimate the mean income of all class members if you chose method 1. Okay. Method 2, despite the smaller sample size, the random selection there is likely to result in a sample that's more representative and produce an unbiased estimate. So I'm not sure exactly what parts of that they're looking for, but we'll look at the rubric and decide. Okay. For part C, there was no part C, sorry. The scoring is scored in 3 different sections. Part B has 2 components. You would need to identify the characteristic for each sampling method, indicate the effect, and then section 1 is just part A. I don't know why they did that backwards. That was really strange. So section 1 consists of part A, section 2 consists of part B, component 1, and section 3, component 2. Whew, that's hard for me. We're 3 sections. We're good. So section 1, it's essential for part A if you described how skewness or outliers affect the mean but do not affect the median. And you had to make a conjecture about something about the distribution of incomes. So you had to say something specific about how a really high income would affect the mean but not the median. Basically, that was context, was using a characteristic of the distribution, right? Yes. Okay. For component 1, examples that are acceptable. The mean is affected by skewness. The median is not affected by skewness. The mean is greater than the median when there is skewness or outliers. So even if you didn't use context, they're saying it would be okay. They're saying basically that one's affected by the median, high outliers would mean that the mean would be greater than the median. You had to put it not necessarily just in context, but in relevance to where the skewness was. Does that make sense? So they're saying that the mean's affected, the median's not, and when there is right skewness, the mean is greater. Or you could have said when there's left skewness, the median's greater. Is that okay? One's greater than the other in a certain situation. Okay, it looks here like component 1 examples that are not acceptable. You can't say things like don't use the mean for skewed distributions with outliers. Wonder why that's not. Use the median for skewed distributions, or for outliers. You had to specifically say that the mean is affected, the median is affected. Therefore, in this case, one would be greater than the other. You can't say, we should use this. That's what they're saying, okay? So just basically making statements. All right, the second section would be for making sure you chose method 2 and said a relevant characteristic of method 1 and a relevant characteristic of method 2. Basically, you had to talk about the randomization in method 2. And in method 1, you had to talk about the response bias. Or is it non-response bias? Sorry. Oh, voluntary response bias. Okay? Responses that do not explicitly choose method 2 can still earn an E. What? If the choice is clearly implied. So if you clearly imply method 2 but didn't say method 2, I'm not sure where that would happen, but I guess that happened in some people's responses. Anybody do that? Anybody not say, I choose method 2, but meant it? No? Okay. If it asks you to choose one, please say so, okay? Because it looks like you need to. It says responses that compare the two methods can satisfy both components. If you say like one would have more non-response versus the other, and you're actually just comparing the two, that looks like that would be an okay way to answer this question. Discussions of inference is extraneous and should be completely ignored. Anybody try to bring in inference into this question at all? Good. Okay. And then the last section here, it's essential if you indicate the incomes of responders may be different than the incomes of non-responders. That is always going to be an answer if we're talking about voluntary response bias. People that answer the question their answers are going to differ in some way than those who don't answer it. Okay? So you always want to make sure that that sentence is included in whatever answer you're providing. There's some reason why this group of people didn't answer the question. Their answers are going to differ in some way than the ones who did answer it. Okay? You're going to also need to indicate the bias sampling method may produce a misleading conclusion about the mean income. The sample mean is likely to be higher than the mean of the population. I'm not sure we would say that, but if you did. It does say here that a single sentence can satisfy the first component of section 2 and the first component of section 3. For example, in method 1, rich people are more likely to respond. You've said you've identified a component about the thing. You've said in method 1, this is going to happen, right? All right. How'd y'all do? EPI, I would imagine that it would probably, most people would have scored in about that situation. Did you guys score yours as we went through? You want to go back through it one more time? Because we're going to have to score somebody else's paper in a minute. No? What'd you get, Sammy? EPP? EPP? All right, so let's see what an EPP would have gotten us. So 1, 2, 3, or 4. Hang on, what does it say we have to add them to be? Whoa. Hang on. Does it say each point is 1 point? Oh, it doesn't. Hang on. There we go. Okay. So EPP looks like a 2. Okay, 1 section essential and 1 or 2 sections. Even if you got an EP or an I, it would still be a 2. So EPP or EPI is a 2. So look at yours and see how you did. Anybody get above a 2 out of curiosity? Good, Maddie. Okay. All right. Let's go ahead and look at the papers that you guys have. If you guys wouldn't mind sharing those. Brian, if you would join the group behind you in the chair. I provided 1 sample paper that the College Board has provided. I want you to give it a score. Oh, they're in the printer. I'll be back. All right, so I just realized I'm not sure of how much of what we just talked about was on the recording because I've only been recording for 15 minutes. Oops. Well, most of us are here, so that worked out all right. So we're going to go ahead now and transition to topic 5, which is the last topic of theme 1, and then we are going to jump to theme 2 today, but we'll finish off theme 1 as the first. So if you look at topic 5, it's talking about marginal frequencies for two-ways tables, conditional relative frequencies, and association. What hypothesis test would be linked to this type of data? Chi-squared, okay? So we want to think about a chi-squared if we're talking about, because oftentimes on free response questions on the AP exam, they'll ask you some questions about a contingency table, and then they'll kind of combine it with some portion of a hypothesis test. They'll kind of look at both of those scenarios. But two-way tables, you want to think chi-squared tests, okay? So here we have on page 113, which is the next, this question. If you go ahead and look at it for me. So do you have your theme 1, Hunter, or are you just going to play on your phone? Oh, okay. Yeah, why don't you put your phone away for me, love? Yeah, okay, sounds good. So if we look at this particular question here, it says that 800 registered voters, the data are cross-classified. We have gender and whether or not their opinion on some bond issue. So I want to be able to find the marginal and conditional distributions. Let's just refresh our memory. What is the difference? What's a marginal distribution versus a conditional distribution? Let's start with marginal. A marginal distributions means you're going to use the margins, which are not listed here. Okay? So we're going to be looking at the sums. And so what do we get here? 600 and 200. For a total of 800 in each case. What is that? 610 and 190. I'm just double checking my addition. Did I add right? Okay. You want to make sure that you include your totals on yours. You don't have yours either? Okay. I don't know if I have extras of theme 1 or not, but I'll look. So what would a distribution be for a marginal distribution? We want to look at a marginal distribution for gender. So marginal is going to have 2. So marginal distribution for gender is going to say what? We're going to have males and we're going to have females. So what numbers am I going to put that would go with both of those? The males would be 600 out of 800. You can reduce that if you'd like. Okay. The females would be 200 out of 800. Okay. Now we're going to look at their opinion on this, whatever it is, this environmental bond issue. They're either going to be for or against. And these would be the marginal distributions. So for would be 610 out of 800. And against would be 190 out of 800. We're good so far? Those are the marginal distributions. When we look at conditional distributions, we're looking at different things. What are we looking for with conditional? We're looking at the numbers in the columns or in the rows. Okay? So if we're looking for conditional distributions, I'll use a different color. Okay, we wanted to look at, let's say, gender. Okay, so we would say that we have men in the 4 would be 450 out of 600. And you would have 150 out of 600. You with me so far? Just for the men. What am I comparing that to? Nope. When we're trying to show independence, we compare a marginal to a conditional. So this conditional distribution, what am I going to compare it to? I can compare it to women. I could also compare it to the opinion, right? Does this have the same breakdown approximately as just the general opinion? Do men differ somehow from the general opinion of the bond issue? That would be, are they independent? Okay? So does men have a different opinion for or against than the general population? You could also compare the men to the women and see if those percentages are different as well. Are we okay with that? I'm just doing the gender right now. I could do women as well if I wanted, but we okay with answering that question to at least this part? Okay. So again, what do I compare? A couple of options if I'm trying to show independence. The conditional to the marginal, or all of the conditionals to each other. Okay? I'd write that down if that's something you don't know. So let's just compare real quick. What is 610 divided by 800 and 190 divided by 800? So I have about 0.76 and about 0.24. And then we'll compare those down here to 450 out of 600. I get 0.75. And I have 150 out of 600, which is about 0.25. What do you think? Are they independent, yes or no? Do you want them close or do you want them far apart? You're very different things. So let's think about it. Let's rationalize our answer. If the men have the same distribution as the general population, is gender independent or dependent? Independent. So the closer they are, 0.76 to 0.75, pretty close. 0.24 to 0.25, pretty close. We want them to be close because proving them close says they're independent, approximately. We don't know for sure by actually conducting something, a chi-squared test, right? But we could say, based on that, we could say that because these are close, gender and opinion are relatively independent. Let's use a fake word. Okay? The conditional distribution and the marginal distribution are pretty darn close. Okay? All right, next question. If you'll go ahead and flip. This is something hopefully Devin or Brian can help us figure out, because for whatever reason, these things always make me crazy. You guys remember? Let's figure out what the value should be for n. I'm going to pause the recording for just a second. So I agree with 75, but I need y'all to explain it. Okay, go ahead, Isaiah. Shh. Right. In this particular case, I could have gone the other direction. It wouldn't have mattered, right? 20 over 50 equals 30 over n. Wouldn't that have worked too? Doesn't matter. And oh, it's over n. Sorry, not I wrote 75, but it's over n. And then just cross multiply and solve for n. You want those proportions to be the same. Once the proportions are the same, then the distributions would be equivalent. Okay? Good? Oh, what happened? What happened? Remember this from a long time ago?
Yeah, I was here.
Okay, so the answer is 75. All right, so this concludes theme 1. I do have some copies of theme 2, which is our next major unit, so let me pass those out. So we will start theme 2. We're not going to finish it. It's obviously going to be for you to finish for homework. But theme 2 is the second portion of the curriculum, which deals with experimental design. It deals with all the vocabulary stuff, types of bias, surveys, observational studies, all that kind of stuff. So that's really where we're at with this theme. Now, one of the things that I learned at the Mason experience over the weekend was that experimental design questions haven't come up recently, so we're due, is what they say. I don't know what that means exactly, but, right? And also, something else I learned at the experience, remember how I said that you really aren't going to have to be able to create a data display? They'll give you one to look at. Guess what the first question was on the practice exam? Make a dot plot. Okay? And so we probably, before we get into the next theme, because theme 1 really talked about, oh, I'm sorry, Brian, talked about data displays, didn't it? Every single person except for Amanda, I think, on the practice exam forgot to label their axes in context and automatically took you from an E to a P. So one of the things on your theme 1 review packet, you absolutely 100% need to write label your axes, okay, in context. Oh, sorry, Tanner. Sorry, guys, I didn't mean to miss you. I promise. There you go. All right. So that is something please write on theme 1. I guess I haven't seen you, them ask you to create a data display in so long. I just kind of assumed they were phasing that out of the curriculum. But apparently they're saying we're due for it. Okay. Who knows? I agree, but I'm just telling you what I was told. Yes, ma'am. No. There's no way that they could test every concept that we've ever done. There's just no way. Thank goodness, because that you'd be there for the entire day. They typically pick a hypothesis. I mean, they will have questions from each of these themes, but there's no way, like there's so many topics in probability that we've covered alone that there's no way they could hit all of them. But they will hit questions from one of each of these themes at least. Okay? But going back to, so theme 1, big thing, label your axes. You don't want that to bring you down from an E to a P, right? Just that one thing. So hint on Thursday, well, that we're doing multiple choice Thursday, never mind. But when we get to the free response on the Mason practice exam, you'll see what I mean. Theme 2. One of the main things I learned because one of the questions was a design and experiment, was that remember how we had to draw when we designed an experiment with the arrows and stuff like that? That is okay, but not enough. Okay, of an experimental design description. If you are asked to create an experimental design, they want you to discuss your randomization process in detail. They want you to discuss how many people went into each treatment group. They wanted you to discuss the word control. They want you to just like write it out. Like just write it, write in words. A picture is okay, but if you remember, when we did experimental design, we just did like treatment groups like this, and then we said 30, 30, 30, and we said that they were randomly placed. You remember what I'm talking about? Into whatever? That word randomly is not enough. You had to discuss that you numbered them from 1 to blah, 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 and, explain your randomization procedure, that kind of thing. So that's just kind of an FYI. I personally still like them because the diagrams help me, but apparently that's so 1997, whatever that means. So they basically said that, yeah. They're like, that's so 1997. Okay, thanks. I was upset because they made me feel old. But that's okay. So we're going to move up with the ages, and we're going to learn to do what they ask us to do, okay? So let's start with some topics to review on data collection. Lots of vocabulary in this theme. We have, do we know what a census is? Do we know what an SRS is? And, oh, by the way, when you're doing, let's just talk about the difference. So one of the questions that came up over the weekend was an SRS and a, what did they have you do? Hang on, I want to use the right terminology. Give me a different type of sampling method. Cluster, systematic. Let's write them all down, that's fine. Okay, these aren't the ones I'm thinking of, but that's okay. That one was. We have cluster sample. We have, what else? Stratified. And you said another one? Systematic, right? And then we have SRS. All of which are different, right? All are different from each other. What is a cluster sample? How would you identify it? One thing that has all of the groups inside of it, right? So if we're interested in learning about freshmen, sophomore, junior, seniors, we could pick one high school. That would be a cluster. It would have all of the subgroups within it, correct? Stratified's different. What's a stratified sample? When I look at the population, I'm not taking a subgroup now, the population, and I'm breaking it up into groups, right? Okay? I'm going to look at all the freshmen separately, all the sophomores separately, all the juniors separately, and I'm going to sample from within those groups. So it's kind of like the way I like to look at it is that we break into groups first, and then sample. Whereas a cluster, what do? I look at the group and then look at the, I look at the sample and then look at the group, right? I sample first. So I sample first and then look at the groups. Which way a cluster sample or stratified sample is going to ensure that all subgroups are sampled? Stratified. Because you're going to be looking at the different criteria first and then dividing them up according to the criteria and picking some from each group. A cluster sample cannot guarantee that everybody will be represented. Would you agree with that? Because what if I picked Patriot when it first opened? No freshman class, right? So that kind of thing. I meant that, you know what I meant, not what I say, what I meant. Yes, no senior class. Okay. Systematic. What's the systematic again? Okay, so like every 30th person in line, that kind of thing? Yeah, okay. How would that become random? Thank you. I would have to randomize where I start. Otherwise, every person wouldn't have an equally likely chance of being selected, right? So that's an important. So systematic, you have to randomize the starting point. I agree. Okay. And then an SRS. What's that? It's a simple random sample, but what is it? Numbering everybody and using a random number generator or a table somehow and selecting people at random. What's going to be important is that when you number the people, either you write their names on a slip of paper and throw them in a hat, but if you're going to use a random digit table or a random number table, what do I have to be careful about with numbering? We'll get to that one in a minute. Double digits versus single digits? If I'm using a random number table, I can't use 1 to 100. I have to use 001 to 100, right? Remember that? So we have to be careful if we're using a table that we use a consistent number of digits. That came up over the weekend. Okay, some people, when they were doing sampling, they described a sampling method in which they used a random number table, but they didn't number it correctly. If you use your calculator, you can. But if you're using a random number table, you have to use the same number of digits every time. So like 1 would be 001. Okay, remember that from when we did that stuff before? Okay. Now, something that came up over the weekend is that people were talking about a stratified sample. And that's exciting because, you know, that's one of the questions said, why would it be advantageous versus the other? But what one of the students said was that you're going to break them into groups and then perform an SRS on each group. So you're using two different methods, and that doesn't happen. And that there's only two ways to do an SRS. One is to put everybody in a hat or a ball or a bowl or something, stir it up, and pick them out, right? Or the other one would be to number everybody and use a table to randomly select them. It's the only way to do an SRS. The minute you start stratifying and breaking them into groups, you are no longer in the SRS category. You are now only in the stratified category. Okay? I thought that was very interesting that those, no one in this class, by the way, but in some other papers we were grading, it got blurred. So I wanted to make sure I was very clear about the distinction between the two, or the four, really. What makes an experiment an experiment? Treatment. So one of the questions over the weekend said, is it an experiment or an observational study? If it's an experiment, you have to say there are treatment groups, okay? So that's what you're specifically looking for when you're looking for an experiment. If it is an experiment, you need to say it. There are treatment groups involved. There is a treatment. Now, within experimental design, we have some good things we always want to see, but it's not an experiment no matter what. It could be a bad experiment, but an experiment nonetheless as long as there's a treatment group, right? There could be an experiment that says, you know, I'm going on a diet. I'm going to eat jelly donuts every morning. That's a bad experiment, but there's a treatment group, right? There's a treatment. The treatment is jelly donuts, right? Not a good one, but nonetheless there's a treatment. Let's just kind of review. What are the 3, sometimes 4 key elements of experimental design that we always need to deal with? Give me one. Randomization. And where do we randomize? Am I randomizing like systematically? I'm going to pick every third person in line and give them a jelly donut? Can't do that. I'm randomizing what? What treatment group they go in. So I'm going to take my volunteers. Who wants to come on a diet with Miss Macker? Come meet me in room 3002, whatever. And then I'm going to say, okay, now I'm going to take the people in this room, and I'm going to randomly put you in a diet group. Okay? Question? You sure? Okay. Oh, give me another one. Go ahead. That's all right. Replication. Okay. I think of it that way too, actually. And there's 2 different kinds of replication. You know what they are? Where can we replicate? Stephanie? That's something else. But within replication, there's 2 kinds of replication. I can repeat the entire experiment again. Is that what you meant? No, what do you mean? Multiple people. So multiple people in each treatment group? Multiple subjects in each treatment group? Yes. That is one form of replication. So if I have 40 people in each treatment group, I have introduced replication because each treatment group has more than one subject in it. Okay? I can replicate an experiment by doing it all over again, but why is that probably not a good thing to do? Money, time. So it's good when you design a good experiment that you do it good from the beginning. All right, what's the third one? Control group, okay? And a control group can be either a before and after design, right? A before and after design, you could You could weigh everybody before the jelly donut diet and then weigh everybody after the jelly donut diet and see how well we did. The before would be its own control, right? So that would be the control we'd be using. And then 4, Stephanie, would be the sometimes we use blocking. In an experiment, which is different than systematic sampling, oh, that was still up here. Sorry, stratified sampling is different than blocking, right? With blocking, that's an experimental design term. Why do we block and how do we block? What is blocking? Okay. Okay. Okay, so we're going to block before treatment group, so we could have often genders used as a block, and then we would do our treatment groups within each block, yes? Why are we blocking? What do you mean by that? Yep. What could happen? Thank you. That's what I wanted you to say. Okay. We actually block because we're trying to make sure that whatever variable we're blocking by, whether it be gender or age or whatever, we don't want that particular variable to confound the experiment, right? We don't want it to produce a reason that the results are the way they are. We want to make sure that we think that females are going to have a different response than males. Let's say we're talking about weightlifting, okay? I can guarantee you that every boy in this room can lift more weights than Miss Mackert can, all right? But females typically go less than women, right? Females, no. Females less than males. That's, again, what I mean, not what I say, okay? But that's why we block. We don't want those underlying other variables to come into play or to affect the results in a certain way. Okay? So let's go ahead and do the first couple together, and then the rest I'll leave for you. So again, we're looking at Roman numerals 1, 2, and 3. And let's see what we can come up with this particular question. I'm going to pause it for just a second. So these are actually true statements. Okay, all of them are. So the answer is D. Let's talk about which, because almost more than half of us got it wrong. So tell me why. Which one did we think was not true? Number 2? All right, let's look at number 2. In an observational study, information is gathered on an already existing situation. That is true.
Well, if 3 is true, then doesn't do have to be true because an observational study is a sample survey.
Well, I think number 2 is talking about when you look at something in the future, and I think maybe, were you thinking of this in terms of a retrospective study? Is that what that was bothering you? You thought that was the word? A retrospective study is an observational study. There are 2 kinds of observational studies. There's 3 really. When you have observational studies, you have 3 situations. You can have a retrospective study, you can have a prospective study, and you can have a survey. All 3 of those are situations, right? And then we could have an experiment, right? So it's kind of like where we are in this situation. I guess really a survey is not really considered, that should be fine. We'll leave it that way. So all 3 are correct. Okay? A prospective and a retrospective studies are under that big umbrella. So hopefully that will help you with number 2. All right, let's go ahead. I think we should probably wrap up here. Okay, we got about 5 minutes left. I am going to ask that you answer the rest of these questions for homework. Okay, and I realized, listen to me please real quick, I realize the temptation of just, because there's not a whole lot of math involved in these questions, the temptation is just to go and circle a bunch of answers and say, I did my homework, Ms. Beckett. Please take this seriously. This is your AP grade. This is your potential college credit on the line, okay? So please do that for me. Thank you.